A scientific experiment conducted by local researchers is revealing surprises about marine creatures and how they might live in the future. Academics have found that sea snails survive better in acidified seawater when they're infected by parasites. Dr. Colin MacLeod of the University of Otago's zoology department joins us to explain. Good evening.
Good evening.
Tell us about the experiment and what you did.
So essentially I'm interested in how ocean acidification is going to affect host-parasite associations, which is a bit of a mouthful. But really what I did was expose infected and uninfected snails to acidified seawater to see what happened to their survival rates and a number of other parameters.
What were your main findings?
So interestingly I found that healthy or uninfected snails actually had a higher mortality rate in acidified seawater than infected snails.
Why acidified seawater?
Well, ocean acidification is a global process that's going on at the moment, and essentially the same carbon dioxide that causes global warming is dissolving into the seawater and going through a number of chemical reactions and causing seawater to become slightly more acidic.
Okay. Now, how did these flatworms help the sea snails?
Help's a little bit of a relative term there. The parasites, once they infect the snail, actually sterilize the snail, so they destroy the reproductive organs of the snail and replace them with their own reproductive apparatus. But the theory goes that the energy required by reproductive activity is actually greater than the energy that the parasites take away. So infected snails essentially have more energy to cope with stressors such as acidified seawater and therefore exhibit less mortality.
And so what happens when they do try to reproduce?
Very little.
Yeah.
Yeah.
So they will effectively become extinct?
Well, they're not really a reproductively active part of the population anymore, but about 20% of the snail population in Otago Harbour is uninfected, and they seem to be reproductively active enough to keep the population going.
Are you surprised by the results?
Yes and no. Yes, I'm surprised because ocean acidification typically has negative effects. Parasitic infection also typically has negative effects in most cases. And it's surprising that anything positive comes out of those that combination of factors. But some people have found that actually growth rates of infected snails increase compared to uninfected individuals, so that suggests, or I thought that maybe there would be an excess of energy that could go towards regulating against an acidified environment.
What does it mean in terms of marine life dealing with future changes in the ocean?
So it's difficult to extrapolate from one study that looked at one type of parasite and one type of host. I think the major message in my research is that people need to start looking at the effect of parasites in case they make incorrect judgments on the reaction of marine organisms. If I'd included both infected and uninfected snails in my analysis, I wouldn't have detected this reduction in survival.
So have any other sea creatures been studied in this respect?
Many sea creatures have been studied in terms of ocean acidification, but so far, there's very few researchers that have actually looked at the combination of parasitic infection and ocean acidification.
Tell us a little bit more about the acidic nature of the ocean and why it's becoming more so.
Essentially, the carbon dioxide that we produce through fossil fuel combustion is in a large part, or about 30% of the CO2 released in the last 200 years has been absorbed by the ocean. So actually, if the ocean wasn't there, we'd be a lot warmer right now. But carbon dioxide just dissolves into the seawater, goes through a number of chemical reactions and releases hydrogen ions, which essentially is how we measure pH, so the pH goes down.
How quickly is it happening?
On a day-to-day scale for us, not very quickly, but in, say, the scale of the last 400,000 years, the rate at which ocean pH is changing now is unprecedented.
Is it likely to be cyclical?
No, it's pretty much a one-way system. If we start to curb carbon dioxide emissions, then maybe in time the pH of the ocean will go back to pre-industrial levels, but at the moment it looks like this will be a fairly permanent change.
Is this the end for your research on this one, or will it continue?
No, I'll be continuing to look at how parasitic infection and ocean acidification interact over the next little while. It's an area that I find extremely interesting.
Absolutely, and we look forward to the results. Dr. Colin MacLeod from the University of Otago Zoology Department, thanks so much for your time.
Thanks very much.